In this video, we will understand the difference between distance and displacement and the difference between speed and velocity. Please write down the title, distance, displacement, speed and velocity, and then answer these 5 questions. Pause the video now and press play once you're done. You should have now answered these 5 questions. Please now mark your 5 questions with these answers here. Pause the video and mark your answers now. The unit over here, meters per second, should be written like this, m/s, or you could also write the unit meters per second like this. We're now going to really try and understand the difference between distance and displacement. Distance is a measure of how far you've travelled altogether, how many meters you've travelled altogether. So in this diagram here, we're going to look at a journey from A to D. But the journey is going to go from A to B, and then from B to C, and then from C to D. I'd like you to please work out the total distance travelled in going from A to B to C to D, and then say your answer to the screen. So you should have got an answer of 11.5 meters, because to go from A to B is 6 meters, and then from B to C is 1.5 meters, and then from C to D is 4 meters, which in total is 11.5 meters. So the distance travelled in this situation is 11.5 meters. It's the total amount of ground covered in the journey. That's distance. Displacement is different. Displacement is a measure of how far you are from where you started. So in this journey, the person started at A and finished at D. Now they went on a very interesting path, going from A to B to C to D, but they started at A and they finished at D. So displacement is how far they are from where they started with a direction, because displacement is a vector quantity. So look at the diagram and say to the video how far the person is now from where they started with a direction. So they started at A, they finished at D. That means they are 6.5 meters away from where they started. Because they started at A and finished at D, they are to the right of where they started. So they are 6.5 meters to the right. And that is their displacement. So in summary, distance is just the total amount of ground covered during the journey, usually measured in meters, whereas displacement is a measure of how far the object is from its starting position with a direction. Distance is just a scalar quantity, a total amount of meters. Displacement is a vector quantity, a measure of how many meters you are from where you started with a direction. We're now going to do this example together. Pause the video and read the question. So the first part of the question asks, what is the distance travelled? So let's do this together. I'd like you to work out how far is travelled altogether when the car goes from A to B to C and then back to B. What is that total distance? So you should have found out that the total distance from A to B, that's 5 kilometers, and then from B to C, that's another 4, so we're at 9 kilometers, and then from C back to B, that's another 4, so altogether we have 13 kilometers. So we have 9 plus another 4. So the distance traveled is therefore 13 kilometers. Please convert that to meters and say your answer to the screen. You should have got 13,000 meters. Part B says, what is the displacement of the car from its original position? So its original position was A, and it's finished at B. So I'd like you to work out how far the car is from its original position and in what direction. Say your answer to the screen now. So you should have said that the car is now 5 kilometers to the right of its original position. It started at A, over here. It's done a whole different journey. It's gone from B to C and back to B, but it doesn't matter about the whole journey. The point is it's finished at B. So it started at A, I'm going to label that 1, and it finished at B, I'm going to label that 2. So the distance of its finishing point from its starting point is 5 kilometers to the right. What is 5 kilometers in meters? Say your answer to the screen. Hopefully you've said 5,000 meters. So the displacement of the car from its original position is 5,000 meters to the right. Please now do these 5 questions. Pause the video and then rejoin the video once you're done. I would like you now to please mark your work using these solutions here. Pause the video while you mark. I would just like to go through questions 4 and 5 in a bit more detail to make sure you fully understand. So for question 4A, what is the displacement from B to A? So that means if you started at B and you finished at A, how far are you from where you started? So I'd like you to please count the squares directly from B to A. So not the whole black path, just if you go on a direct line from B to A, I'd like you to count the squares and say the number to the screen. If you've done that correctly, you should have got that there are 13 squares if you draw a direct line from B to A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 squares directly from B to A. Put an arrow to show we're going from B to A. Each square is worth 2 meters, according to the scale down here. So therefore we have 13 squares, each 2 meters. So that is 26 meters. Also, we need to include a direction. Why do we need to include a direction? Hopefully you've said because displacement is a vector quantity. So 26 meters. So say the direction that you think the displacement is. Well, you should already know from the solutions that it is left, because if you start at B and you finish at A, you have moved to the left. Now for the distance traveled, it's different. The distance traveled, we don't want to know the direct line from B to A. We want to know the total of the whole journey. So I'd like you now to count the squares for the whole journey from B to A, and then say your answer to the screen. You should have counted 27 squares. Again, the scale is 2 meters. So we've got 27 squares, which are each 2 meters. 27 times 2 is 54 meters. Now, distance is what type of quantity? Distance is a scalar quantity. Therefore, what do I not need to include in my answer? I don't need to include a direction. So that's the full explanation for question 4. For question 5, things are a little simpler. So for 5A, what distance have you traveled? Well, the whole journey is 1,006 meters for one journey around the roller coaster, and you're staying on for 3 trips. So 3 trips, 1,006 meters each. Oh, 1,006, that is 3,018 meters. Distance is what type of quantity? So it doesn't need, so you should have said distance is a scalar quantity, so it doesn't need a direction. And for part B, what is your displacement from your starting position? Well, you've gone around the roller coaster, and then you've gone around again, and then you've gone around again, but you finished where you started. So your distance from where you started is 0 meters, because you're back to where you started. So even though you've gone on a very long journey, a journey over 3 kilometers, your displacement is 0 meters, because your distance from where you started is 0 meters. The next thing we're going to look at is the distance between speed and velocity. So I'd like you to pause the video and write down what you think the difference is between speed and velocity, and then press play. So there's various things you might have written down. I would have expected most people to write down from their prior knowledge that speed is a scalar quantity and that velocity is a vector quantity. But I want to really, really understand what that means. So I'm going to draw an arrow, and this arrow represents the motion of an object, and the object I'm going to represent just as a dot. So we have an object, and it is moving to the right with a speed of, let's say, 5 meters per second. And then I'm going to have another object, and this object is moving to the left with a speed of 3 meters per second. So for each of these objects, their speed is just how fast they're going, regardless of direction. So the speed of this object is just 5 meters per second, because this object is moving 5 meters every second. The speed of this object is 3 meters per second, because it's moving 3 meters every second. Velocity includes what? You should have said that velocity includes direction. Why does velocity include direction? Hopefully you've said because it's a vector quantity. So therefore, for this one, the velocity, it's got a speed of 5 meters per second. So its speed is still 5 meters per second, but it's to the right. And for this object over here, what do you think the velocity is? Say your answer to the screen. Hopefully you've said that the velocity is 3 meters per second to the left. So that's the difference between speed and velocity. Now, what that means is when you are using the equation which links speed, distance, and time, it is slightly different depending on if you're talking about speed or if you're talking about velocity. And I'm going to show you that with this example here. So please pause the video and read the question and then press play. So we're being asked to find 2 different quantities from the same question. So we're going to start by finding the average speed. So to find the average speed, we need the formula for speed. So please say to the video, what is the equation to find speed? Hopefully you've said that speed is distance divided by time. So I'm going to write that because we always write the equation first. Okay, what is the distance? You should have said 50 meters. It doesn't explicitly say distance in the question, but you should realize that if you've got a measurement of 50 meters, that is the distance. But wait, that's what you might write if you're not being careful. Hopefully you didn't actually say 50 meters. Hopefully you realize that if Joe has run to the end of the street and back, and the street is 50 meters long, how far has Joe actually traveled? Joe has actually traveled 100 meters. So Joe's distance is 100 meters. How long did that take him? It took him 20 seconds. We can see that over here in the question. Now, I included the units. In reality, you don't need to, so I'm going to delete those. As long as you're putting in the numbers using the correct units. So the standard units for distance, please say that to the camera now. Yep, it's meters, and the standard units for time, seconds. So we already had those numbers in those units. So 100 divided by 20 is 5. And what are the units for speed? Say your answer to the camera. Well, to the video. 5 meters per second. Now, speed is what type of quantity? It's a scalar quantity. So therefore, what do we not need to include? We don't need to include a direction. Now, velocity is different. If speed is distance over time, what's the equation for velocity? Say your answer to the video now. The equation for velocity is displacement divided by time, because we need to link the vector quantity to the vector quantity. The scalar quantity speed is the scalar quantity distance over time, but the vector quantity velocity is the vector quantity displacement over time. So, looking at the question, what do you think the displacement is? Pause the video, have a think. Once you're ready, come back to the video. Well, since Joe has run to the end of the street and back, he's now back to his original position. His distance from where he started is 0. So his displacement is 0. The time is still 20, but 0 divided by 20 is 0. What are the units for velocity? Say your answer to the video. The units of velocity are meters per second. So even though he's definitely moving, even though he definitely had an average speed, his velocity is 0 because his displacement is 0, because he's got back to where he started. And that can be a surprising result. It might seem strange that Joe has actually gone on a journey, but his average velocity was 0 meters per second. I should add at the beginning here that these are the average speed and the average velocity, because at any point in his journey, Joe did have an actual velocity. So let's say he ran to the end of the street in 10 seconds. He did have a velocity of 5 meters per second in the direction he was going. And then when he came back, if he did that in 10 seconds, he would have had an average velocity of 5 meters per second coming back the other way. But overall, for the whole journey, his displacement was 0. So therefore, for the whole journey, his average velocity is 0. So I'd like you now to do these questions. Please do them and pause the video. Please now mark your answers using these solutions here. Pause the video while you do that. I would just like to explain questions 3 and 4 in a little bit more detail for those who got it wrong. So if you got questions, any part of question 3 and 4 wrong, please continue watching the video. If you got all of those questions correct, you can now end the video and please like and subscribe. Okay, so let's go through questions 3 and 4 for those who made any mistakes. So for average speed, we need distance divided by time. The distance covered altogether is 400 meters, and the time is 120 seconds. You can always use a calculator when you're doing physics. So 400 over 120 is 3.3 meters per second. I always leave at least one decimal place. For the student's average velocity, though, we don't want distance over time, we want displacement over time. The letter we use for displacement is S. Because the student has run around the full track and got back to where she started, the displacement is therefore 0. And when you do 0 over 120, you get 0. Finally, question 4. So for average speed, we're going to do distance over time. Now, if they started at C, went to A, and then back to B, they will have traveled 9 kilometers from C to A, and then from A to B, another 5 kilometers. 9 plus 5 is 14 kilometers. What is 14 kilometers in meters? Say your answer to the video now. 14 kilometers is 14 14,000 meters. So therefore the distance is 14,000 meters. The time in the question is 40 minutes. What units do we need to turn that into? So your answer to the video. We need to turn it into seconds. How do you turn minutes into seconds? You times by 60. 40 times 60 is 2,400 seconds. And that's the units we have to use in the formula. So we do 14,000 divided by 2,400. And you can always use a calculator when you're doing physics. So the answer is 5.83 meters per second. Finding the average velocity, though, is a different question. Finding the average velocity, we need to know, okay, they started at C, and then they did a whole journey, but in the end, they finished at B. So how far are they from where they started? How far are they from where they started? Well, if they started at C and they're now at B, they are only 4 kilometers from where they started. So they are only 4,000 meters from where they started. So therefore, we do 4,000 divided by 2,400. When you do that on your calculator, you get an answer of 1.67 meters per second. Velocity is what type of quantity? It's vector. So what do you need to include? A direction. So if they started at C and they're now at B, what direction are they compared to where they started? What direction have they moved in overall? The answer is to the left. I hope this video helped you to understand the difference between distance and displacement, and also the difference between speed and velocity. Please like and subscribe so that you get access to any other videos which I post.